As you can see, I got um, unexpected event that in which I had to cut the video last video. But okay, let's keep on going. So now we're gonna look at the what the lab manual gives you, and it gives you C4H10. We studied these isomers anyway. This is the number of electron and it's tetra in every carbon. And as you see, what they did here is move this. You see, this is the same as the linear. This is the last, but what they did is move this group here. They move it up here. Okay, so that is a structural isomer. So how do you draw the 3D? Because it gives you that two isomers. Those are the two isomers. How do we draw the CD? The 3D. By the way, the Lewis structure for both is going to be basically the same as you see. But it's with the position of when you have to draw the Lewis structure for several isomers, you have to draw it and then do all the same thing. Bonds, electron pairs, lone pairs for each isomer. I'm not going to ask you for that. But let's go ahead and draw the sketch. H, C, again, see what I'm doing. You see? C, 1, 2, 3, and 4. It doesn't matter. And here I can put, the lab manual says that I can put in the extreme the CH3 and that's it. So here you got on the front, you got one of the hydrogens. And on the back, you got the other one. Here, you got on one the hydrogen and the other one. And here, of course, you got your hydrogen up and here. And that's the Lewis, and that's the 3D for the polar, non-polar. All of them are hydrogen, carbon-hydrogen bond. Let's go to the next one. Okay, let's go step by step. Now this one, right, we got C2. I'm gonna do it on the right and then in the box because I don't think it's gonna fit. C2H4Cl2. C2, this, then I was going on C2H4Cl2. C2H4Cl2. Okay, we have two central atoms, two carbons. Now, this is the one that we did, and it's 1Cl here. Let's do it up and down. I mean in Cl here, the other Cl here, right? And we got 1H. No, let's do it on the right. And 1H. Now, what's going to happen? Count the electron. 8 plus 4, 12. Plus, it has only one Cl or Cl2? Cl2, yeah. Cl2. And plus 14 is going to be 26. So let's start by putting the electrons here. What I'm doing is looking to see if it has structural isomers. But I'm doing the Lewis structure here too. So it's going to be 2. Well, we'll finish the Lewis structure, but see what I'm going to do here. If I change this chlorine here, is going to be, I explained it today during lecture, it's going to be a structural isomer. So it's going to be C, Cl, C, Cl, H, H. You see, that is a structure. Now, if I rotate the molecule, even this is a double bond, by the way, but we'll see that if I rotate the molecule and it goes down or here, it's the same. If the chlorine is still on this carbon, the only way it would be a structural isomer if this chlorine would be in the same carbon than this one. That's the only way. So yes, there is, but it's only two isomers. So let's draw the Lewis structure for both isomers. So we got here 1, 2 is 26, right? One chlorine here, one hydrogen, one chlorine, one hydrogen, and then we got a single bond here. Then we'll look at the. It's not gonna fit. Well, yeah, I can make it fit. So here would be, what if we put the two chlorine? Those are the two isomers, and we have to do it for both. H, H. Now we have 26. Then 1, 2, 3, 1, 2, 3, 4, 5 is 10. 1, 2, 3, 4, 5. So it's going to be minus 10, 6. So we have minus 10, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What if we put, no, okay, 2 is 8 plus 4, for hydrogen plus 14 is gonna be 18 plus 8, 26, yes. So 1, 2, 3, 4, and 5 is 10. So we have 16 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Hmm. Let me see there's something I am doing now that I can't catch it up because maybe I'm very tired and I can't see what it is. This is number 10. That's why I have my notes, because just in case I am tired like now. Okay, I'll start again even if we lose time. One, see, I wish you were there to tell me what is wrong. One here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Here you got 2 carbons is 8, plus 4 oxygen, plus 14, 12, plus 14, 16. I'm going to have to stop the video. I can't see it. Because I know it cannot be a triple bond here. Because if it's a triple bond, right, then you wouldn't be able to have 2 hydrogen and the chlorine. I'm doing the calculation of the total valence wrong. I, this. Okay. I'm doing something here that it doesn't fit. 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16 on this side. 18, 20, 21, 22, 23, 24. 1, 2, 4 bonds on the carbon. And that's why I put the double bond. You automatically can put the double bond here because you have 4 bottom. Let me do something. Let me recheck my calculation and everything and my notes, and I'll come back because there's something I'm doing that it's wrong. Okay, I'll discover what it was. I was just putting only 2 hydrogen and it's 4. So it's gonna be 1 here, right? And I'm going to have to erase everything back. We're still going to have the same isomer. Let me show you. Okay? I was putting two hydrogen. What in my life? What in... That's crazy. One, two. So let's look at the first one. One chlorine here, one chlorine here. So we got one hydrogen, one hydrogen. We're not going to bond them yet, okay? And remember, we don't mind if it's a double bond, okay? And it's just going to be a single because you only need one to be a four bonds. So we are going to make it one single like we usually do on the Lewis structure. Now we have four hydrogen. Now it's the right. Now if you count 26, you're going to count 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7 by 2, 14, 16, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Now I got it. We still have the isomer, what I said, just two isomer. Why? Structural. Because the only thing that it's going to make a structural isomer is that if we put the chlorine in the same carbon. That's it. Remember, that's the concept of structural isomers. That's the only thing that could make a change. And that would be, let's put it over here, wherever you want, because it is equivalent all of the other positions. And in fact would be optical, or would be, in this case, optical, or could be geometric. So here, this would be the H. Okay, we change the chlorine, this H for chlorine, and this would be the second isomer. Okay. So the same thing here, right? Now these structures are very similar. The Lewis structure is basically this one and this one. What you need to do is draw it. Make sure you have all the electron. You make sure you have the octet. Chlorine has 6 plus 2, 8. 6 plus 2, 8. Carbon, 4 bonds, 8, 4 bonds. And the duet for the hydrogen, the same thing here. So they are complete. All the electrons are complete. Formal charge of carbon. Do you remember how to calculate the formal charge of carbon when it has 4 bonds? And it's that we did it already. For carbon would be 4 minus 4 bonds plus 0 lone pair is going to be 0. For the hydrogen, again, you know it's 0. I did it 100 times. And for the chlorine, it's 7 minus, I've done it so many times today, 7 minus 1 bond plus 6 on shear is going to give you 0. 7 minus 7, 0. Okay, so all of them are 0. As it is so packed, in this case, I'm not going to put it. In fact, that's what the lab is saying. I say, no, we'll put it. No, I don't. I'm not going to do it here. For the exam, yes, I'm going to ask you to put even the zeros because I want to see it. I need to see it so I can, if you have something wrong, it's better to find it out now. So T2, what structure? Again, we have the 4 bonds to the carbon, right? So it's going to be, and 4 of them are bonds, 0 lone pairs, 4 domains in which all of them are atoms, no lone pairs. So it's going to be tetra on every carbon. Okay? Now let's do again the D for both isomers. So it's going to be chlorine here, and it's going to be, let's put a hydrogen here and the chlorine here. You see here, you're going to see something. This is this one on the bottom, okay? This isomer. So here you got the hydrogen, and then you're going to have, yeah, you're going to have here another hydrogen, and here the hydrogen. What would be the difference with the other isomer? Well, that you would have the chlorine here, here the other carbon, but here you're going to have the other chlorine. Do you see the difference? So this is the hydrogen, hydrogen, and here instead of the chlorine would be another hydrogen, and this would be the hydrogen. So those are the two isomers. Polar? Ah, polar. Yes, it is polar. Okay? Why? Because you have different domains on each one. Remember, one is carbon and hydrogen, which is counted the same as the polarity are identical, almost identical. So the chlorine would be a different domain. So yes, it is polar. Polar. Where is the polarity going? The vector is going this way and this way. Do you see the resultant is going up? And here is going on this one going here and here, the same one. Okay, so it's going this way. hmm Because it's equivalent. It's not like the cis and trans isomer. So yes, it is polar. Now let's look at the next one. We have carbon, three carbons, right? One, two. I'm gonna have to do it in it because you're gonna have isomers. You're gonna see that we have isomers here, structural isomers. We got one, two, and three. Okay? Where do we put this oxygen? Let's put it on here. Okay? Now we got one hydrogen, two hydrogen, three hydrogen. Let's bond it single bond. Four, five, six. I know it's not like that. Seven. Where do we put the other one? Oops. Here. Eight. You see how it comes by itself? Now, what would be the second one? What if we move the oxygen inside? And those are the two typical isomers we've seen until now. Hydrogen, hydrogen. Now we got decided that we're going to move this oxygen on this and move this carbon here. Okay? So you're going to have the oxygen here in the middle, and this is a dimethyl ether. One, two. No, it's sorry. One, two, and three. Methyl ethyl ether. It is. Let me count the atoms, not do the same thing as I was doing a little while ago. Oops. 1, 2, 3, 4, 5, 6, 7, 8. And here we have 1, 2, 3, 6, 7, 8. One oxygen and three carbons, three carbon. So those are the two structural isomers. Yes, you have two. Because if we put the oxygen on the other side, it's going to be the same as this one. So this is no different. If we put it between these two, okay, let me draw it and then I'll erase it here. If we decide to put it instead of it between these two, we put it between these two, see what's going to happen. Oops. Okay, so you have the three hydrogen, 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 hydrogen. Two here. You need the four bonds. Hydrogen, hydrogen, and hydrogen. Do you see this is the same as this one, but flip around like this? The right here is going to be the left here, and the left here is going to be the right. So it's the same. It's not structure or isomers. That's what you need to do. Draw the possibilities and see which one are equal, which one are really different, which one are equivalent, which one not. So here we got it. Let's finish our Lewis structure. 3 by 4, 12, plus 8 plus 6. I'm counting the valence. 12 plus 8, 20, 26. Did I put the valence here? Yeah, 26. So here we go. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bonds, which is 22. So 26 minus 22 is 4. We need 4. Let's put lone pairs on the oxygen. Hydrogen cannot have it. And carbon doesn't like it. And beside carbon, we put all the 4 bonds. So we have these two. How about this one? We have the same, so we need to put them here too. 1, 2, 3, the same number of bond. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 22. Formal charge. We know already, I'm not going to do it again, that the formal charge for carbon is 0 and hydrogen 0, 0. Let's look at the formal charge of this oxygen. That's the only one we have to really pay attention now carefully. And it's the oxygen. Let me leave it there to see. The formal charge of the oxygens here are, okay, we have, which is the same because you have 2 lone pairs and 2 bonds. So oxygen would be equal to the formal charge of oxygen would be 6 minus 2 bonds plus 4 unshare equals 6. 6 minus 6 equals 0. So this is a perfect Lewis structure. Okay? So what is the shape? Again, we have tetrahedral, and you have to look at this as one only domain. Okay, this is one domain, this is another, and this is another. You're not going to analyze the oxygen because oxygen is not the central atom. So what you have to do is look at this as a whole domain, that the group OH would be a whole domain. That's the way you see it. So it's going to be tetra in every carbon again. Okay? Tetra, all carbons. Now, and it's going to be, of course, 4 domains, 0 lone pairs, 4 bottoms. Now, if you look at this for a second, right? If you look at this, are they all the domains identical? No. Here you have hydrogen and carbon, which is the same, but then you have an O here, an OH. So yes, it is polar. This is a polar molecule. So an alcohol is a polar molecule. So this is propanol and this is an ether. So now what do we have? And by the way, what are the domains here? 1, 2, 3, and 4 for this carbon. 1, 2, 3, and 4. It doesn't change anything, you see? So it's polar. Both of them are polar. So I'm gonna draw the 3D. Okay, the third carbon. Now, how are we gonna do this? You're gonna put the group OH here. Don't just put the OH like this, and then you'll have hydrogen, hydrogen. This is like too big. And then you have on here. Let me draw, it's not gonna fit here. Let me draw on bottom here the one for this one, the second isomer. And it's gonna be, we can see it from here. It's C, right? This is the best way to represent it. O, the H here, this is a C. Me. Try to draw it a little bit nicer. C here, right? O, H, and H, right? Then, what do you do? I think it's kind of like this. But remember, everything was going to be 109.5. Is this 120? No, I think I got it right like that. Yeah. So it's going to be the other carbon. How many do we have? Three? Yeah. And then carbon, for example. And then we do all the hydrogens. And here, not the lone pairs. Here you got one over here. Let's put it on top. Doesn't matter, remember. Okay? You can do that because it's the same. So here you got this one hydrogen here. No, I got it wrong. You see what I'm trying to look for? The angle, 109 angle on the plane. And then I put one on front and one on the back. So I have to look for approximately 109.5. And this would be one of the hydrogen. And then here, of course, then I draw the one on top, the one on front, and the one on bottom. Okay, let's do the next one. We have 8 two carbons plus 7 plus 5. That's 12 plus 8, 20. Now let's draw it to just in case to see if there is any isomer. And of course, carbon is in the central atom, and then we got nitrogen. And it's gonna be 1, 2, 3. Those are 1, 2, 3, 4, 5. Has to be on the hydrogens, and the nitrogen 6 and 7. 1, 2, 3, 4, 5, 6, and 7. Is there a possibility that it could be a structure isomer? Yes. Let's draw a different one. And you by now should know already that you can put the nitrogen in the middle of the two carbons. Do you see? With one hydrogen. Let's count them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Let's do the finish the Lewis structure. So yes, we got two isomers, okay? Oops. Again, remember the carbons are the central atom. So your domains are going to be hydrogen, 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 and this whole NH. Carbon would be the second, hydrogen, 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 and the NH. On this case would be hydrogen, 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 and carbon. For this one would be carbon, nitrogen, the NH completely because this is terminal. So we have 20. How many bonds? One, two, let's go with the top one. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 18. We need two more electrons. Where are we going to put it here? Let's check the octet. This you know already, the duet hydrogen and the carbons already have 4 bonds. Octet. Okay, now let's check the one in nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. How about this one? The same thing, but the two lone pairs are going to be here. And that's the Lewis structure. Let's check the formal charge for the nitrogen. Carbon and hydrogen we know is 0. And for the nitrogen would be 5 minus 3 bonds plus 2 on share equals 0. Excellent, Lewis structure. Now, what is the two central atom? What is the geometry and shape? Would be again tetra tetra for both carbons. Let's draw the 3D. This one, I think this is a little bit not like this because then it's gonna be 120. I think, I'm not sure. Hold on, I'm not sure about that because I saw it with the oxygen like that, and this one, and like this one, like this, I would say is like that. This is 90. So a little bit more, yeah, it's okay. This was right. So this is nitrogen. We can either put it, but NH2, and that's it. And so we put our hydrogen on this carbon on front and one on back. And this would be the same for this one. Hydrogen. And then here would be the nitrogen, okay? And you put it with NH2, or you can put the H up, no, NH2. Yeah, hold on. You can also do it like that. But it's okay because the lab model, to simplify, put it like that, NH2. And then you do C, and then you have the 3H here, so one would go up front, the other one on back. Here would be carbon, so I'm thinking about which one, yeah, it would be here, the hydrogen, and then it would be one here and the other one back. And that would be 190 degree, don't forget. I'm gonna stop it here and go because we're almost, well, not almost finishing, but we're moving on.